Hey everyone, I'm Scott Milburn, Master Trainer at Aquatherm. Today we're going to give you an overview of the fusion outlet installation process. First, let's discuss some of the tools that you're going to need. The main things that you'll need is a drill with the appropriate drill bit to actually drill the hole. We're going to need a reaming tool to clean up that hole that we drill in some cases. You'll need a torpedo level in order to level the fitting after you install it. It's also helpful to have a centering tool like this. We can use it to make a mark on the pipe to keep our drill bit from walking when we actually do our drilling process. And then a simple hardwood dowel like this is going to help us keep the iron balanced when we actually go to heat up the two pieces. Additionally, there's other tools that you can use. You can see we have a couple mounted here. These tools can fuse various sizes of fusion outlets, but they function as assistance tools, so they can help us drill the holes, they can help us hold the fittings in alignment and fuse them in, and like I said, they're available to fuse lots of different sizes, so just consult your local tool rep to see what tool is best for you, or if just installing by hand is going to be the most efficient process. So now that we've seen the fusion outlet assist tools that you can use to help you in this process, the next tool that you're going to need to complete a successful fusion outlet is an iron. So we have irons like you've probably used before on socket fusion, except now we need to use the specific heater adapter heads for fusion outlets. Just remember that depending on the fusion outlet you're using, in this case, this is the fitting that we're going to be working with today, just make sure that you size your heater adapter heads to match the to match the branch diameter of the fitting, as well as the main diameter of the fitting, the saddle here that's actually going to fuse onto the pipe. Additionally, keep in mind that the iron temperatures should be the same as socket fusion, meaning they should be at 500 degrees plus or minus 18 degrees Fahrenheit in order to do successful fusion outlet fitting. So the first thing that we need to do is mark on the pipe where we're going to install this fitting. So for that, I'm going to use a Sharpie, my centering head, and then my dowel here. So you'll probably measure from some location to where you want that branch outlet to be. Okay? Next, we take our centering head here, and I'm going to place it on my mark, and then I'm going to go ahead and make sure that the mark that I make is perpendicular and aligned to the pipe. It's important to make sure that that mark is exactly on the top of the pipe. That way when we drill the hole, that hole isn't shifted either forward or backward, which would cause the hole that we're going to drill to be off center, and it's not going to heat properly when we get to the heating stage. So now that we have our mark on the pipe, I'm going to grab my drill and I'm going to make the hole. So I'm going to make sure that the pilot bit on this drill, and make sure that you're using the correct drill bit for the fusion outlet that you're going to be installing. I'm going to line up the pilot bit with the mark that I made, and I'm going to go ahead and drill this hole. Okay. If there's any large burrs or material hanging off of that hole, you can use your reaming tool to clean it up. So now that we have our hole drilled, we're going to clean the surface of the pipe as well as the fitting that we're going to be heating up. So just like other processes, we're going to use 91% isopropyl alcohol and a lint-free cloth to do our cleaning. So now that everything is clean, I'm going to go ahead and check the temperature on my iron. So make sure you have an infrared thermometer or a contact pyrometer handy to measure this temperature. And remember, it should be 500 degrees plus or minus 18. Right now I'm measuring about 503 degrees. So we're right where we want to be. Now the heating process for fusion outlets is a little bit different. with butt fusion or socket fusion, there was always a specific heating time that we needed to observe in order to heat the fitting and the pipe properly. With fusion outlets, the heating time isn't specified. Instead, it's a visual process that we're going to use to gauge whether we've heated the pipe and the fitting sufficiently. So what we're going to do is, depending on the size of the fitting that you're using, you may want to insert the fitting and the pipe onto the heater adapters at the same time. Sometimes for smaller fittings, it's better to insert the iron into the pipe first and then put the fitting on the iron. It just depends on the pipe size and the fitting size that you're using. So when we're heating up these two pieces, what we need to look for is a bead that forms all the way around the heater adapter on the pipe and on the fitting. So as you can see, I'm using this dowel here to help put a little bit of pressure onto the iron there. It makes it easier to insert. But remember, you don't need to put excessive amounts of pressure on that iron to get it into the hole. What we need to do is we need to be patient, and you got to let the iron you got to let the heat do the work. Now that the iron is seated on the pipe, I'm going to go ahead and insert my fitting onto the heater adapter. So at this point, I'm going to add just a little bit of pressure to the top of the fitting, just enough to maintain contact between the pipe and the heater adapter and the fitting in the heater adapter. And I'm going to hold this iron as steady as I can. I don't want to rock it, I don't want to twist it. I just need to maintain the contact between the fitting and the pipe surfaces with the heater adapters, and just let the heat diffuse into the two pieces and develop those beads all the way around the pipe and all the way around the fitting. So make sure that as you heat these, you should be checking on both sides of the iron to make sure that bead is forming evenly on both pieces. So you can see that bead growing. Once it's reached the appropriate size, we're going to take the iron out of the pipe, take our fitting off, and you're going to insert the fitting into the hole. And you're going to insert that fitting far enough until those beads touch, and then you're going to push down just a little bit further until you see a little bit of material push out of that fusion joint. Just to that small bit of movement of the material there tells us that we got good contact across that saddle surface. Now you're going to have a little bit of time while the material is soft to level the fitting. So to level it, you're just going to push down on the high side a little bit to level it off. Make sure you check it in both directions to get it properly leveled. There we go. All right. So as you can see, now that we have this installed, what do we need to look for? Primarily for fusion outlets, we need to see complete beads from the pipe and from the fitting all the way around that fusion joint. As you can see, we have a consistent blue bead all the way around here, and it's also present on the back side. And we also have a consistent green bead all the way around the fitting. That's also present on the back side. There's no gaps between the beads all the way around, and that bead is very consistently sized all the way around the pipe and the fitting. So this is what we want a fusion outlet to look like once it's done. In terms of cool downs, the fusion outlet cool down is going to match the socket fusion size of the branch. Okay, so what that means is, in this case, this is a 3/4 inch branch. You would find the 3/4 inch or 25 millimeter cool down time in the socket fusion tables, and you would use that to measure the cool down of this fusion outlet fitting. Once you reach that cool down, you can pressure test it, you can put it into operation, or move on to the next joint in your project. So now that we've seen how to install a fusion outlet, let's take a look at a couple of examples where something wasn't done correctly. So there's a few different common mistakes that can be made here. One of those common mistakes is not heating the pipe or the fitting properly. So as you can see here, if you look around this fitting, we've got bead forming from the fitting almost all the way around, but then when you come back to this side, this edge here is still sharp. You can see that the iron never made contact with the fitting right here, and therefore it didn't melt the saddle in that location. Additionally, you can see the same thing happened on the pipe. There's no blue bead in that location either, but there is a blue bead present in other parts of that fusion. So what this tells us here is that either the iron was being rocked excessively or wasn't being held, it wasn't held in an aligned position, and that contact between the fusion surfaces wasn't maintained with the heater adapters. So they didn't heat evenly and they didn't fuse properly. This is another example of an incomplete melt. You can see that the pipe was melted properly all the way around, but the fitting in this case was sitting on the iron misaligned. And so while it developed a bead on one side of the fitting, it didn't develop that bead on the other side of that fitting. That would also be a case of incomplete melt, and you would not want to keep that fitting and pass, and that fitting would not pass a QC. You would need to remove that fitting and redo it. Another common mistake would be fusing the fitting on misaligned. So even though we did get relatively good melts all the way around, if you don't fuse that fitting in squarely, you can see that there's a gap that forms between the saddle and the pipe because it wasn't pushed down far enough and it wasn't fused squarely to actually develop that contact and fuse in that location. Another thing that can happen is not properly aligning the fusion outlet when you insert it. So you can see here that there's a gap between the fitting and the pipe on this side, and there's a almost identical gap exactly on the exact opposite side. So this happens because the saddle of the fitting was twisted when it got inserted. So it's really important to make sure that you align the saddle of the fitting with the curvature of the pipe when you insert the fitting into the pipe so that the entire surface will make good contact and fuse properly. Okay, so now that we've seen the fusion outlet installation process, let's do a quick review. So remember, we want to first mark the pipe in the correct location where you want this outlet. Use your centering head to make a mark on the top of the pipe to help you when you drill so that your drill doesn't walk. Then we're going to grab our drill. We're going to drill that hole. Make sure we drill as squarely as possible. And after we've drilled, we're going to check the temperature on our iron. We're going to insert it into the hole. Then we're going to heat the two pieces together. And remember, the fusion outlet heating process, it's visual, it's not timed. So we need to look for a melt bead to form all the way around the fitting and all the way around the pipe before we stop heating. So once we have those complete beads formed on the pipe and the fitting, we pull that iron out, we fuse the two pieces together, and in those first 10 to 15 seconds, we're going to go ahead and level that fitting to the pipe and make sure everything is aligned. I hope this overview of the fusion outlet installation process was helpful. Thanks for taking the time to watch. If you have additional questions, feel free to reach out to your local Aquatherm representative.